Right now, we have more connected devices than ever, and it's getting harder to remember exactly where everything is, which is why many companies have been releasing multiple various asset tracking tags. And wireless distance measurements is also getting another major improvement with the newly announced Bluetooth channel sounding feature. The Bluetooth group has steadily released new features for developers to not only communicate with their devices better, but also to help locate our devices. So exactly how are we doing this? Well, one current method uses the Received Signal Strength Indicator, or RSSI for short. Think of this measurement as how well two devices can hear each other, kind of like when you're having a conversation with a friend, and how clearly you can hear them depends on how far apart you two are. Once a phone establishes a connection, the RSSI measurement can then be used to estimate the relative distance between two devices. And to improve reliability and help triangulate the direction of a device, the main hub can share its BLE connection parameters with multiple nodes and also allow them to measure RSSI. This naturally lends itself to a car access application where a phone's BLE connection to the car can help enable certain features like unlock or ignition start. This RSSI-based approach is currently supported with our CYW20829 and 89829 Bluetooth LE MCUs. It's commonly known that RSSI is prone to noise interference, and its logarithmic nature makes it more suitable for applications that only need coarse measurements. For more precise distance measurements, this is where the newly introduced Bluetooth channel sounding feature steps in. While channel sounding is not a new concept, its standardization within Bluetooth helps ensure interoperability across devices. So how exactly does channel sounding work? Well, there are two new device roles in channel sounding, the initiator and the reflector. There are also two distance measurement approaches, phase-based ranging or round-trip timing. Both devices can choose to use either approach or a combination of the two for improved accuracy and security. Fundamentally, channel sounding leverages the properties of waves in its relationship with wavelength, speed of light, and frequency. Without getting too much into the physics of a wave, what we need to know is that the waves have a physical length, and points along this wave are known as the phase of a wave, with one full wave cycle having phase values ranging from 0 to 2 pi. So the general idea here is that with phase-based ranging is that when a signal is transmitted and reflected back, there is some phase offset. With this phase offset, we can estimate the distance, like for example, if there is a phase offset of pi, then the distance would be half of the wavelength. Of course, in reality, the math behind the calculations is quite complex, and the challenge is to develop an algorithm capable of handling all the spatial components of a wave traveling in three-dimensional space. And because waves cross the same point at every half wavelength, a common issue of range ambiguity appears. And with some additional clever math on multiple phase and frequency differences, we can help to reduce this effect. The other measurement approach, round-trip timing, is exactly as it sounds. Both devices note the time of arrival and departure of a packet, and then uses this to calculate the total round-trip time. By dividing this time in half, we can get the time of flight, which we can then multiply by the speed of light to get the distance. Round-trip timing also has an added benefit of security, since the timestamp itself can't be reversed on the devices. And these two methods combined in the new channel sounding feature can help provide improved distance accuracy and security for many device positioning applications like Find My, and keyless entry for cars or door locks, and proximity geofencing. Infineon will continue to develop with the latest LE features like channel sounding for its existing and future product portfolio. So stay tuned as we continue our development. Thanks for watching.